Okay, so welcome back to part 2 of Biome Notes. We're going to pick up right where we left off last time with temperate rainforests. So to start off with, I'll just tell you this is more of an obscure biome. This isn't like a hugely prevalent biome, but it has moderate temperatures and high precipitation. And where we mostly find them, and the ones that we probably mostly know of in our country, are going to be up there on the west coast of North America, up in California, all the way up to Alaska. You also have some of these in southern Chile and on the west coast of New Zealand and on the island of Tasmania. So I'll show you guys where they are on the map. They're pretty obscure. So we said it's coastal biome. So the big thing with that is that you have ocean currents that are going to help to moderate the temperature fluctuations. They might be located in places that would normally be a little bit colder, but because they're right there by the water, it's going to help to create more of a mild temperature. Also, because they're right there on the water, they're going to end up having high precipitation levels, which is going to allow for huge trees. And it says this biome has nearly a 12-month growing season where winters are rainy and summers are foggy. So example of trees that you might know of in this particular biome are those coastal redwoods out in California that are enormous. You might have seen pictures of these trees. There's one that you can actually drive through that I've seen pictures of. Some of you might have visited these. They also have large firs, spruces, cedars, and hemlocks. Because they've got all these nice, big, beautiful trees, one of the environmental issues that they face is they have heavy logging pressure due to all those great tree resources. And just like other biomes that we've seen before, they're going to have a slower decomposition rate. And then once they do decompose dead matter on the ground, plants are going to either quickly uptake those nutrients right away to satisfy the needs of these huge trees, or they're going to leach the nutrients down into the soil. And what leaching means is just basically these nutrients kind of infiltrate and get drained down into deeper levels of the soil, so they're not really available to the roots of the plants. So due to these issues, the soil here is actually going to have a low amount of nutrients. So this is what a temperate rainforest might look like. I wish I had a picture of a large redwood tree, but I can show you guys some of those in class. Here's where we find them in North America, over here on the upper west coast. We said you can find them down here in Chile, and then you have a little bit over here in Australia. Okay, so now on to our biome, which is the temperate seasonal forest, aka your temperate deciduous forest. Let's see. So we get a decent amount of precipitation. We receive over 1 meter of precipitation annually. We have warm summers and cooler winters. And a lot of these temperate deciduous biomes experience all 4 seasons. They're found in the eastern U.S., Japan, China, Europe, Chile, and eastern Australia. They are dominated by different types of deciduous trees like beech. This should be maple. Sorry about that. I corrected it on here. Oak and hickory. And as I mentioned just a second ago, a lot of these temperate deciduous forests experience all 4 seasons, because with these deciduous trees, they drop their leaves in the fall so that they can go dormant for the winter. And then once the days start getting longer and spring comes back about, you'll see them regrow their leaves when they come out of their dormancy. So even though we might find our biome kind of boring, we should actually feel kind of lucky, because we're one of the few biomes that gets to experience these 4 very different and distinct seasons. So it says we have warmer summer temperatures that are going to aid in the decomposition process. So what do you know? We finally have a biome that actually has pretty good levels of nutrients in our soils. At least we're going to have more nutrients in our soil than the boreal forest. Some environmental issues that occur in this biome. They're very popular for agriculture because of the good soil, and then also for residential areas. We've got a high concentration of people that live in the eastern United States that are all in this deciduous forest. Oops, I went the wrong way. Back this way. Okay, so here's your temperate seasonal or temperate deciduous forest, highly concentrated over here in eastern U.S. You got a lot over here in Europe as well, a little bit over here in southern Asia area. And here's what we typically see, especially this time of year, with all the leaves changing colors as they're getting ready to drop their leaves to go dormant in winter. And then if we look at your climatogram for the temperate deciduous forest, they give it a 12-month growing season. And we've got fluctuating temperatures throughout the year, obviously much warmer in the summer and colder in the winter, and a little bit of fluctuation in your precipitation throughout the year as well. Okay, this next one is called the chaparral, and this is also kind of a more obscure biome. It's also known as your woodlands or your shrublands. I like to think of this as kind of your vineyard biome. Wherever you see vineyards, a lot of times these are chaparrals. So they're found, a lot of times they're found on the coast, so coast of Southern California, Southern Australia, Southern Africa, and a lot of the Mediterranean area. Again, these are all places that are famous for their vineyards producing wine. Hot, dry summers and mild, rainy winters are characteristic of this biome. They do have a 12-month growing season, but the plant growth is mostly constrained due to low precipitation in summer and low temperatures in winter. So you have different constraining factors at different times of the year. Some issues that this biome can face is that they have common wildfires, but the plants are well adapted to deal with both fire and drought-like conditions since it can get kind of dry at some points. And it says many of the plants have evolved seeds that can resprout after a fire, and many of the plants are drought tolerant to begin with. So examples of the types of plants you might see in the chaparral are the yucca, the scrub oak, and the sagebrush. And what do you know? We have another biome that is low in nutrients in the soil, and these are mostly due to leaching from the rains in the winter. This land is popular to use for grazing animals and for farming drought-tolerant crops like grapes, which is why we see a lot of vineyards, because grapes can deal with drought pretty well. And the dry soil can actually affect the grapes and the winemaking process and all that sort of thing. So this is what a chaparral or a scrubland might look like. As I said, they're more obscure. This is where you might see them. We see them in Southern California, like Napa Valley is a perfect example of that. Mediterranean area, a little bit of Northern Africa, Southern Africa, and then Southern South America, and then a little bit of Australia as well. And then, as we said, you've got different constraining factors. So at one point of the year, your temperatures drop. At another point of the year, your precipitation drops. But it can get dry, and as we said, they have drought-tolerant plants because of that. Your temperate grassland. So it's a temperate biome, but it says out of all of the different types of temperate biomes, it has the lowest amount of rain. They can have cold, harsh winters and hot, dry summers. You have different categories of these temperate grasslands throughout the world. If we're talking about the temperate grasslands in North America, we call those the Great Plains, but the nickname is the prairies. In South America, we call the grasslands the pampas, and then in Central Asia and Eastern Europe, we call them the steppes. The plant growth is constrained by both insufficient precipitation in summer and cold temperatures in winter, so again, different constraining factors there. Plants include grasses and non-woody flowering plants that are well adapted to wildfires and frequent grazing by animals. So a lot of similarities to the conditions that we just saw in the scrubland. Excuse me, where we do see some low amounts of precipitation, which could yield things like drought, and then you've got the fire issue as well, especially in dry biomes like that. I apologize. Okay, so some of your environmental issues here are wildfires and overgrazing. But it says wildfires can actually help to facilitate grasses grow, but it usually inhibits tree growth. That's why we don't see a whole lot of trees out there in the prairies. And then it says over 98% of the tall grass prairies in the U.S. have been converted to agriculture. That's a big thing in our country because it's worked out well for us. And then short grass prairies we've used for growing wheat and grazing cattle. One of the reasons that we do all of this stuff on the grasslands is for this reason. The soil is actually really, really good. So it says, due to a long growing season and rapid decomposition, the soil has good nutrients and is very productive. Okay, so here's what the prairies might look like. Here's your tall grasses and some bison grazing out there, it looks like. And then here's your location of your temperate grasslands. You've got the Midwest of the U.S. You've got a lot of Asia over here. And then if you look at your conditions, looks like both, well, we said precipitation can get low, but compared to other biomes, it's not too bad. But out of all of the temperate biomes, it is said to be the lowest precipitation. And then the temperatures can get really warm in the summer and then really cold in the winter. And then a 12-month growing season. Okay, tropical rainforest. This is going to be your most biodiverse terrestrial biome. So it says, in the tropics, annual average temperatures exceed 20 degrees Celsius, and precipitation occurs very frequently. And this biome is very warm and wet with little temperature variation. So a lot of their conditions that they have the very similar conditions all throughout the year. So no 4 seasons here. They might have a little bit of seasonal fluctuations in precipitation level. You might have a dry season and a wet season, that sort of thing, where they have like really heavy rains compared to not as bad rains, but nothing like what we have here with the 4 different seasons. And in fact, if they're located right near the equator, the length of their days is probably the same all year round too, where they have like a perfect 12-hour day and a perfect 12-hour night. When I went to visit a couple of places in the Caribbean, it was like that, where it's 5 a.m., sunrise, 5 p.m., sunset, and it's like that every day all year long. This biome is located approximately within 20 north and 20 south of the equator, so right around the equator. You see a lot of rainforests in Central South America, Africa, Southeast Asia, and northeastern Australia. Tropical rainforests are going to have more biodiversity per hectare than any other terrestrial biome, and they contain up to 2/3 of Earth's terrestrial species. So they're what we would consider a biodiversity hotspot. Tons of species, tons of wildlife there. And we'll talk about what a hotspot is in our next unit. It's going to be one of those places where you want to focus your conservation efforts, because we will be able to save way more species if we focus on places that have a lot of biodiversity. So as you can imagine, if you have warm temperatures and a lot of rain, you're going to have really high productivity, lots of plants, lots of plant growth, and you're going to have really fast decomposition. However, because the plants take up the decomposed nutrients very quickly, almost as quickly as they're being decomposed, they leave few nutrients behind in the soil to accumulate, which translates to a low nutrient level in the soil. And a lot of people wouldn't imagine that a tropical rainforest has low nutrient level in its soil, but it's true, and it's because of that fact, because decomposition happens really quickly, but the plants uptake those nutrients almost as quickly as the nutrients are made. A common environmental issue in the rainforest is agriculture, but it says since the soils lose their nutrients so quickly, a farmer will farm an area of land for just a short amount of time, and then he'll have to move on to a new piece of newly deforested land every few years. So that increases deforestation rates. It happens very, very quickly, and we'll talk about that more in our next unit. Okay, here's what a tropical rainforest would look like. And then again, we said you have a lot of these in Central and South America, Africa, Southeast Asia. And then high temps and high precipitation. And this shows us in the Philippines. Looks like they do have a dry season here around March and April. And then it picks back up in the summer, and then you get a really rainy season around July and August. Okay, tropical seasonal forest / savanna, and then the savanna I've always referred to as your tropical grassland. So this textbook likes to combine these two things together, but just for the sake of, when I'm talking about in class, talking about a savanna, know that we're talking about a tropical grassland, and I think I mentioned this before, I call this the Lion King biome. So characteristics of this biome, you would have warm temperatures and definitely a distinct wet and dry season. So tropical seasonal forests, which are otherwise known as tropical deciduous forests, you'll find these in Central America, on the Atlantic coast of South America, Southern Asia, Northwestern Australia, and Sub-Saharan Africa. Lion King. Soil in this biome is fairly fertile, and it can be farmed. It's used frequently for grazing and agriculture. Due to high decomposition rates, but the low amount of precipitation can constrain plants from using the soil nutrients that are released. Grazing and fire discourage growth of smaller woody plants and keep the savanna landscape open. So you will see the occasional trees, and that's what this is saying here. You'll see the occasional tree, but a lot of it is grasslands, and you do have a lot of grazing and fire that can occur. So it says trees in warmer temps can make the savanna unique to other grasslands, and grasses and scattered deciduous trees, that's a common look for the savanna. And examples of types of trees that you would see in the savanna are the acacia tree and the baobab tree. And if you've ever been to the animal kingdom in Disney, the baobab tree is that tree of life. It has a very distinct look to it. Okay, so here you have that distinct savanna look, a lot of grasses, some trees scattered about. Here's your location: Central and South America, Sub-Saharan Africa, Southeast Asia, a little bit of Northern Australia. And here you really see the wet and dry season in the climatogram. Temperature stays relatively stable, but your precipitation really swings. The wet season looks like it's around May, June, July, August, and then it starts to trickle down in the fall. Your subtropical desert, this is our last terrestrial biome that we're doing, otherwise just known as your hot desert. We already said earlier that you typically find this desert at about 30 degrees north and 30 degrees south. You're going to have hot temperatures and extremely dry conditions. That's the major factor that determines what a desert is. It has to have a low amount of precipitation. I believe it's like less than 10 inches a year. The Mojave Desert in the southwestern U.S., the Sahara in Africa, and the Arabian Desert in the Middle East, and the Great Victorian Desert in Australia. Those are all very popular examples of tropical deserts, subtropical deserts. Some of your examples of types of plants that you would find in a desert are things like cacti, euphorbs, and succulent plants. Any sort of plant that's going to grow in such a hot and dry biome has to have really special adaptations to do well there. So some of the types of adaptations we would see, they're usually have small, non-existent, or spine-like leaves, and it says they're also usually covered in a thick coating and have very few pores to do the water and air exchange with, because they want to hold on to the water as good as they can. Most photosynthesis in these plants is going to occur on their stems instead of their leaves, because they may not have leaves, or they might just be little spines instead of real leaves. They usually have some sort of painful defensive mechanism to keep animals from eating them, because animals are smart and realize that plants have water that they need to survive. And it says that they have also adapted to grow, reproduce, and die very quickly after a rare rain event, or only do their growth when it actually does rain. So all their adaptations revolve around preserving water and doing all their processes quickly when it rains. You also see a lot of strange animal adaptations for wildlife that lives in deserts. If we're comparing a desert to other biomes in terms of biodiversity, they're going to have relatively smaller amount of biodiversity than other biomes, but the types of adaptations that you see are really cool. You're going to see mammals that have the really, really big ears that help them to radiate heat away from their body. If you do have mammals, they're going to have usually lighter colored fur to help them reflect heat away. You'll have a lot of reptiles and animals that can burrow into the ground to help stay cool or hide in the shade. And then you see a lot of cool digestive tracts that allow them to hold on to water really, really well. They might do something where they don't urinate at all, or if they do, it's very, very little. So they are able to retain water really well. Okay, and so here's the types of plants that you might see in a desert. We know cacti for sure. Here's the locations that we see them. We said typically 30 north and 30 south. So warm temperatures. Ooh, look at that low precipitation. Very, very, very little precipitation. Okay, so we are done with our terrestrial biomes. We just need to talk about some aquatic biomes real quickly. And there's two major categories that we're going to put our aquatic biomes into. The first one is freshwater, which is going to include things like streams, rivers, lakes, and wetlands. And the second is saltwater, which is going to include things like estuaries, coral reefs, and the open ocean. So I'm going to go through these relatively quickly. Okay, So for streams and rivers, it says that they are flowing fresh water that may originate from underground springs or from runoff from rain or melting snow. And a lot of your big rivers really do come from, you've got the big masses of snow that are, we call them snowpack, up on the top of a mountain, and then in the spring when those start to melt, all that water will come down from the mountains and really fill up those rivers. Your smaller bodies of running water are streams, and they're the same thing as creeks. They're typically more narrow, and they carry a smaller amount of water than rivers. Rivers are usually wider and carry larger amounts of water. So that's the difference between a stream and a river. Okay, lakes and ponds. There really isn't any difference between the two. It says lakes are larger than the ponds, but there's no point at which one thing becomes the other. So, like, we have little ponds in our neighborhood. I call them ponds. Some people might call them lakes. Just something to know here. It says standing water, that some of which is too deep to support emergent vegetation. That is the definition of a lake or a pond. And we need to know what emergent vegetation is, because we're going to see that in a couple of these aquatic biomes. Excuse me. Emergent vegetation is going to be plants that are rooted to the bottom of that body of water, and then you would see them emerge above the surface of the water. So lakes and ponds, you don't have that because they're going to be too deep to support that. Okay, there's Lake George in New York. And here's a diagram of the different parts of a lake that we're going to talk about on the next slide. Okay, you've got different zones of a lake or a pond. The first zone, it's called the littoral zone. It's the shallow area of soil and water near the shore where algae and emergent plants can grow, so it's shallow enough where you would see those plants rooted to the bottom and they can actually grow up to the surface. And this is where most of your photosynthesis occurs. So here's your littoral zone around the edge here where you would have emergent plants like this growing up from the soil up above the surface of the water. Limnetic zone is open water where rooted plants can definitely no longer survive, and you're going to have phytoplankton out there as your only photosynthetic organisms. And it says this zone extends to as deep as sunlight can penetrate. And so if we go back, limnetic zone is out here, open water. The profundal zone is a zone where sunlight cannot penetrate and therefore producers cannot survive. And the very, very bottom, it says the muddy bottom of the lake or pond is called the benthic zone. So, limnetic is the open water, profundal is down here where light can't penetrate, and then benthic zone is the actual bottom of the lake. Okay, so now on to our wetlands. So what a wetland is, it says, is an aquatic biome that's submerged or saturated by water for at least part of each year, but shallow enough to support emergent vegetation. They support species of plants that are specialized to live in submerged or saturated soils. So it might be kind of a stagnant water situation, and you have some weird stuff that can take place in these types of things. So some examples of some wetlands would be swamps, marshes, and bogs. A swamp, it says it's a wetland that contains emergent trees. So I'll show you a picture of the swamp here. It's a swamp. We have emergent trees, again, that are rooted down below the water. This is going to be relatively shallow water, probably kind of stagnant, so not a whole lot of movement happening here, but you do have these trees that can emerge through that. Marshes are wetlands that contain primarily non-woody vegetation, meaning like non-tree or shrub-like vegetation, and that's going to include things like cattails and sedges. So here's a picture of a marsh. There's some lily pads. And then the last one, bogs, it says they're very acidic wetlands that typically contain sphagnum moss and spruce trees. So here is a bog. Oops, sorry, I went the wrong way. Okay, some facts about wetlands, because we will talk about wetlands throughout the year. It says they're among the most productive biomes on the planet, and they provide many important ecosystem services. They absorb large amounts of rainwater and release it slowly into that groundwater or into nearby streams. This helps to reduce the severity of floods and droughts. We've talked about this one before. They filter the water. They're a natural filter, so they filter pollutants from the water, and they help to recharge the groundwater with clean, filtered water. and they're a really important habitat for many important and especially endangered bird species. A lot of bird species use wetlands for their migration stopover points or even for their breeding grounds. Unfortunately, more than half of the U.S.'s freshwater wetlands have been drained for agricultural or development purposes. So now you have companies that exist where their entire purpose is to go out there and create artificial wetlands when we've had to drain natural wetlands for development purposes. Okay, a salt marsh. It says that these are found along coast in temperate climates, and they contain non-woody emergent vegetation as well. They are frequently found in estuaries. An estuary is like the Chesapeake Bay, and that's where freshwater and saltwater mix together. They're an incredibly productive biome, meaning you have a lot of plant life and a lot of other wildlife as well, because you've got this really unique situation. You get a lot of biodiversity there. A mangrove swamp. These are found along tropical and subtropical coasts. They contain trees whose roots are submerged in water. So these are special plants that can live here. Mangrove trees are special trees that are tolerant to the salt water, and they help to protect coastlines from erosion and storm damage. So it's really, really important that we protect these mangrove forests because they provide us with all these important ecosystem services for us. They also provide a really important habitat to fish and shellfish. So this is what a mangrove forest looks like. Any of you guys who have visited the Caribbean, you might have actually snorkeled through some of these before. It's really, really cool. You see all sorts of little crabs and fish and all sorts of stuff swimming through there. But again, they're a really important erosion protector and a really important habitat for a lot of wildlife. The intertidal zone is a little bit strange. That is going to be that piece of coastline that exists between when we have high tide and low tide. So the organisms that live there have to be really well adapted to dealing with waves constantly crashing onto the shore. It can try to pull them back out into sea. When the tide is out and you don't have any water and the sun's beaming down on these organisms, they can get really hot and dried out. So these organisms have to be really specially adapted to deal with kind of that rough environment. So this is what an intertidal zone would look like. And the tide is obviously out at this point. Okay, we're almost done. We have coral reefs in the ocean to talk about last. So coral reefs are found in warm shallow waters. They are some of Earth's most diverse marine biome, even though coral reefs are found in water that is relatively poor in nutrients and food. What corals actually are is they're actually animals that secrete a layer of limestone, which is calcium carbonate. We've heard calcium carbonate before. As their exoskeleton. And the animal living inside of this exoskeleton is actually just a little hollow tube with little tentacles. And as the corals die, they leave behind those calcium carbonate skeletons, and these skeletons build on top of each other, and before you know it, you've got this big old reef. So you've got your Great Barrier Reef down in Australia. That's one of your largest and your most famous coral reefs. The major environmental issue affecting coral reefs right now is called coral bleaching. That happens when the algae inside of the coral dies because corals live symbiotically with algae, and so they have to have the algae alive for them to survive as well. So some of the reasons that scientists believe that coral bleaching is happening, there are some diseases that are killing the algae, but a lot of it they say is due to the environmental change that the ocean is experiencing. Higher temperatures in the ocean, lower pH, and we said that lower pH, one of the major causes of the lower pH, meaning more acidic water, is due to all of the extra CO2 that the ocean is absorbing. So this is another one of those issues that we're trying to link to climate change. More CO2 in the water means lower pH, and then also higher ocean temperatures as well. There's a coral reef. Huge biodiversity, tons of fish, tons of organisms live and eat here and depend on the coral reef. Okay, and our very last biome is open ocean. So this just says the depth that light can penetrate in the open ocean is dependent on the amount of sediment and algae suspended in the water. So the photic zone is the zone that receives enough light to allow photosynthesis to occur. So, thinking of your ocean however far the light can get down, that's going to be your photic zone, and you'll have photosynthesis taking place in your algae out there. Your aphotic zone is going to be your deeper water that lacks sufficient light for photosynthesis. So you're not going to have any producers and any producer-based food chains at this point. But something kind of cool that scientists discovered, I think that they discovered this back in the 70s, and it kind of changed the way that we thought about food chains altogether. Scientists found a bacteria deep down in the ocean in the aphotic zone where it's too dark for there to be any photosynthesis. They found bacteria that take in methane and hydrogen sulfide from those volcanic vents on the bottom of the ocean, and they use these chemicals to generate energy. And so they are the producers of these dark food chains at the bottom of the ocean. And again, that totally changed the way that we think about food chains, because we used to think every food chain began with the sun and then began with some sort of photosynthetic producer. But that is not the case, because we have these deep ocean food chains that begin with chemicals and these chemosynthetic bacteria. So that was a really cool discovery. And I think that is it for our biome notes. Yep, it sure is. So thank you guys, and I will see you in class.